Hello, good day to everyone. This is me, Haziq and Fauzi, and this is Budriz.
Hi.
Okay, so we are group 15. For our assignment, we've chosen to analyze the dynamics of an egg. Egg. Okay.
So we are going to analyze what's the differences between letting this egg fall to the ground without and with padding.
So the first part we did in free fall. Second part we did in we analyze it in projectile motion. So you explain your part first, which is the free fall.
Okay, my part is I let the egg fall in free fall motion. I let the egg fall from 90 centimeter from the ground on the mattress and on the bare ground. So as you can see, so this is the condition, initial condition of the egg before we throw it or let it fall. And as you can see,
After the fall.
this is also the after condition of the egg with padding and without the padding.
So and then my part, so same thing like his. We drop one with without the padding and one with the padding. But in this case, I threw the egg at an angle, so the angle like that lah. Okay, so initially, the egg is like this. See, there's no cracks, and then the one that we drop on the ground turn out like this. Okay. Yeah, you see it's quite broken here. It fell like that. And then afterwards, you throw with the padding.
Yeah.
It's like this. Clean, no break, no chala, whatever. Okay. Uish. Tengok. Oi. Okay, as you can see, without the
Padding.
the egg broke. Okay, 1, 2, 3, go. Oi, sikit ambil. Tengok. No crack. Kena tunjuk.
Bad result. Okay, sudah record.
No crack. Positive result.
So this is a close-up of the free body diagram. On the left is for the egg throw, and on the right here is for the egg drop. See the normal force and only the gravitational force downwards, and on the egg throw we have the addition of the force applied. And this here is the energy conservation equation. And as you can see, for the egg throw, the energy before the throw and after the throw is remain constant, so energy is conserved. And same with the egg dropped, energy before the drop and energy after the drop is also the same, proving the end energy conservation.
Hello, I am Daryl, and I'm going to proceed with the calculation for our case, which is I'll start with the LO1, which is to solve the dynamic problems of accelerating particles. So this is the free body diagram of the first case, which is the free fall. So it is given that the mass of the egg is equal to 0.06 kilogram and the initial velocity of the egg is equal to 0. So firstly, we are going to find the final velocity of the egg by using this formula: v square equal to u square plus 2as. The final velocity equal to 4.202 meter per second. Another alternative way to find the final velocity is by using the conservation of energy formula, which is this one. And then if we plug all the value correctly, all the parameters correctly, we are going to get the same answer, the same final velocity as in this one. So for the time taken for the egg to reach the ground can be calculated by using this formula: v equal to u plus at, and then we'll get the t is equal to 0.43 seconds. Next, this is the second case, which is the projectile motion. So given that the initial velocity of the egg is equal to 5 meter per second, And then by using trigonometry formula, we can calculate the initial velocity in both x and y components, which is ux equal to 4.33 meter per second and the uy is equal to 2.5 meter per second. The mass of the egg will still remain constant, which is 0.06 kilogram. So to find the time taken for the egg before it hits the ground, we can be calculated by using this formula, which is the s equal to ut plus 1 over 2 at t square, where a here is the gravitational acceleration. Then plug all the parameters value inside, and then we'll get the time is equal to 0.75 seconds. For the displacement in x direction, we can use this formula, which is s equal to u t. U is the initial velocity in x component, and the t is the time taken. Then we'll get that the displacement in x direction is equal to 3.248 meter. For the maximum height, we are going to need to find the height of the thrown egg first, which is by using this formula, u square equal to u square plus 2as. Plug all the value and we'll get the displacement in y component is equal to 0.319 meter. And for the maximum height, we are going to add with the height of the original position of the egg above the ground, which is 0.9 meter, and then we'll get the maximum height is equal to 1.219 meter. For the final velocity, we can use the formula b square equal to u square plus 2as, which is the a here is the gravitational force and the s here is the difference in displacement in y component. So plug all the parameter value correctly, then we'll get the final velocity in y component is equal to 4.89 meter per second. We should note that the velocity in x direction remain constant throughout the motion. So the final velocity in x direction will still be equal to or remain 4.33 meter per second. So by using this formula, we can calculate v final. So plug all the value, we will get the final velocity equal to 6.532 meter per second. So for the angle of v final, we can use this trigonometry formula. Plug all the parameter value correctly, and we'll get the angle of final velocity is equal to 48.48 degree. Next, for the LO3, which is to analyze kinematic and kinetic problems in vibrating particles. We'll start with the free fall. For free fall, we are just going to calculate the impact force since it has no x component. So here, impact energy is equal to kinetic energy, and impact energy is equal to the displacement times the impact force. So we can find the impact force by using this formula, which if we rearrange, it will become like this, and plug all the parameter value inside, and we'll get the impact force is equal to 0.589 Newton, where the impact energy can be calculated using the kinetic energy formula, which is energy is equal to 1 over 2 mv square. So this is the free body diagram of the egg at the moment it hits the ground, where the initial velocity will be the final velocity from L1, which is 6.532 meter per second, and the velocity angle will be equal to 48.48 degree. We are going to find the velocity after the first bounce and the velocity angle after the first bounce. So all of these parameters value are obtained from L1. So we are going to find the coefficient of restitution by using this formula, where h here indicates the height of the egg after it bounces for the first time, and the uppercase h here indicates the egg height before it hits the ground. So at the end, we'll get the coefficient of restitution is equal to 0.14. Next, we will find the velocity in y direction after the first bounce by using this formula. Then we will get that the velocity in y direction after the first bounce will equal to 0.685 meter per second. Now, after obtaining both the velocity in x and y direction after the first bounce, we can find the resultant force using this formula, and we will get that the resultant force will be equal to 4.384 meter per second. For the velocity angle after the first bounce, we can use the same trigonometry formula, and at the end we will get that the velocity angle after the first bounce is equal to 9 degree. For the impact force, we are going to use the same formula we used in the free fall case, where the kinetic energy is calculated. The impact energy is calculated using the kinetic energy, which is 1 over 2 mv square. Plug all the value here, and we'll get that the force will equal to 1.05 Newton. That's all from me. Thank you.
With that, we've analyzed the dynamics of the egg when it is thrown in free fall and in projectile motion. Now, a bit of explanation of why the egg does not crack once it lands on the mattress is because once the egg hits the mattress absorbs some of the energy in the egg when it is falling, at the same time slowing down the velocity, thus the deceleration decreases, also decreasing the impact force. Therefore, the egg does not crack.
Now, this excellent piece of knowledge is extremely useful in prosthetics. Take lower limb prosthetics, for example. By using things like socket pads and shock absorbing pylons, the force applied on the residue limbs and bony parts can be reduced, thus making the amputee feel more comfortable when wearing the prosthetics and making their gaits smoother.